So when an end user comes to SLS, are they just getting the hardware? I know you mentioned some of the other pieces, but so in this particular dock door, I noticed there's a tablet on the outside of it. Is that something that you guys also provide with your solutions? And how does that connect the reads that they're seeing at the dock door to the rest of their WMS or whatever?
So the partner can provide it or we can provide it, but it's an Android tablet that's driving that. And the biggest thing that we do with that in our software application is we're not actually controlling the door with it, right? The door is doing what it's meant to do, right? It's going to read tags, it's going to run the power settings that we configure on there, and it's going to do that all day, every day. I am just going to subscribe to the events on that with the tablet and capture those, right? So I can take that tablet, if I have 100 dock doors, I don't need 100 tablets, right? I just need one for every fork truck, right? So if I have 10 fork trucks, they can go and load door 3 and then toggle over and load door 2, right? It doesn't have to, it kind of scales with that.
You mentioned the antennas that are internal with an SLS portal. Can you speak a little bit about, you said I can't remember the words you used to describe the antennas that you have inside. You know, most, fixed readers are more of a patch antenna, but is that similar for what your system is, or what kind of technology is in your portals?
Yeah, so it's a multilinear wave antenna. So if you think about, in the industry, you see circular polarized, linear, and then we're in a unique little area of a multilinear. So we have, each antenna has 3 different linear radiators off of it. When when you transmit, if you have a 4-port reader, you transmit to all 4 antennas. With 4 patch antennas, I'm only transmitting out of 4 points. With our solution, we're transmitting out of 12 points, right? Because there's 3 radiators on each antenna, right? And that really what drives diversity, right? If I have 12 points where I'm transmitting that power from, right, there's less chance that I get to an area where there's a null space and I don't see that tag.
Sure. So I'm a little biased because I've heard Matt explain this to me before, but for my viewers, I've mentioned linear polarization, circular polarization on my channel, but also how that affects the orientation of the read when you're going to read a typical dipole. So I mentioned the difference in how you can read the orientation of your typical dipole antenna and why the polarization of the antenna matters. Well, with the multilinear antennas that SLS is using, it sounds like they're omnidirectional. It doesn't matter what the orientation is. That's that's really the biggest spot, right? If you're using a circular polarized, so when we're competing against different solutions with circular polarized antennas, one of them, 50%, likely 50% of the tags that are going through there are going to go through their perpendicular or radial to the antenna. So yeah, the circular polarized antenna, when that tag is perpendicular to the antenna, it's very, very difficult to read. But when it's facing the antenna, it's very, very easy to read, right? And so the delineation between those two is very high. So I have to tune to my worst read to make sure I see it as it goes to the door, right? Yep. But my best orientation is very, very easy to read. Yep. So now I have to worry about cross reads and over reads, right? So a lot of times when we're competing against those two, you'll see where they might run to dive into a little bit, they might run like 18 dBm to see a tag as it's facing the antenna, but as soon as you turn it sideways, it's like, I gotta go to 24. Well, the solution overall has to be at 24 now, right? Sure. Yep. And so when that tag goes through the adjacent door and it's facing that other antenna, I'm gonna read it, right? And so I'm gonna have cross reads, right? So with our solution, we don't see a huge difference between the different orientations. So if I'm running 18 dBm for, the perpendicular orientation, when that tag goes horizontal, I might be 17.5, right, or 17. That difference means I'm going to set the portal to 18 and a half dBm, but that controllability is now I'm reading all orientations. I don't have to go jack the power way up to try to overcome a different orientation. Sure. Something I've mentioned on my channel is, especially when it comes to thermal transfer printing and coding on site, it's always using the least amount of power that you need to, because otherwise you run the risk of reading tags that are in the area that you don't want to read. So it sounds like you guys kind of put the extra effort into kind of fine-tuning your portals so that you're only reading the tags that are in the area of concern, that interrogation zone. So
yeah, and that's to give us that immediate response. That's what we'll always go back to, right? If I tell that fork truck driver when he's 53 foot in the front of that trailer, it's way too late. Now he's got to come back out. He's got to reassess. Sure. I want to tell him as soon as he hits that dock plate, hey, this isn't supposed to be on the truck, or it is supposed to be on the truck, right? So that immediate response, and I can't do that if I add a layer, right, where I have to do some sort of an algorithm to determine did it go in or not, right? It might be 5-6 seconds. That doesn't sound like a lot, but when you load trucks all day, that's a lot.